In this video, I'm doing example 3 from my lecture outline on the simplex method standard maximization problems. So here is the linear programming problem. You can see it is a maximization problem. It says maximize p equals 2x plus y, subject to several constraints. Notice that they are all less than or equal to, and the constants on the right-hand side of the inequality are all positive. This makes it a standard maximization problem. First thing that we need to do is to convert this standard maximization problem into a system of equations. We start with the first constraint. So we have x plus 2y, but instead of being less than or equal to 6, we want it to be equal to 6, which means we need to add a slack variable. If x plus 2y was actually less than 6, and we're changing it to equal to 6, then we would have to add some quantity, s, in order for it to be equal to 6. And so we call that the slack variable because we don't know exactly what that quantity is. Likewise, we have negative x plus y equals 4. And let's let that slack variable be t. X plus y equals 4. And I guess we should go in alphabetical order. That will be u. And then the last equation, we go to our objective function. The objective function must always be on the bottom. And we create this equation by taking the terms on the right-hand side of the objective function and subtracting them to the other side. So we have negative 2x minus y plus p equals 0. From the system of equations, we are going to create our table. We will have an x column, a y column, and a column for each slack variable, s, t, u, p, and then our constant. The coefficients in the x column are 1, negative 1, 1, negative 2. The y column, we have 2, 1, 1, negative 1. In the s column, we have a 1 because we have an s in the first equation, but we don't have any s's in the other equations, so we put in zeros. We have a t in the second equation, one of them, but we do not have t's in the other equations. We have a u in the third equation, but none in the others. And finally, we have a p in the fourth equation, but none in the other equations. Finally, put in the constants. The last thing to do here is to identify the slack variables, the active variables, s, t, u, and p. So we label the rows S, T, U, and P. People forget to do that. It's very important that you make sure that you label the rows with the active variables. The next step is to determine the pivot. And so to determine the pivot, we go to the bottom row. And we look for the most negative number in the bottom row, which is going to be negative 2. And so that column that the negative 2 is in, which is the x column, is our pivot column. Our pivot number is going to be a positive number in the pivot column. So that means either this positive 1 or this positive 1 will be our pivot. To determine which one of those ones is our pivot, we have to find ratios. And so we go over here to the constant, 6, divided by the 1, and we get 6. Then we go to this 4. 4 divided by 1 is 4. Now the pivot will be a positive number in the pivot column that is in the same row as the smallest ratio. So that means that this will be our pivot because it is in the row of the smallest ratio and it's in the pivot column. So once we know what the pivot is, our objective is to clear the pivot column. That means that we want to make every other number in the pivot column a 0. And we do that using good old-fashioned row operations that we learned in the last unit. So let me get rid of this. To clear, let's go to blue. To clear the X column, let's create it. Well, I'll create a new table before I do anything. X, Y, S, T, U, P, and C. And so we need to change 1 into a 0. And we always want to start with the row that's going to change plus or minus the pivot row. So it looks like all I have to do is row 1 minus row 3. So 1 minus 1 is going to be 0. 2 minus 1 is 1. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 1 is negative 1. 0 minus 0 is 0. 6 minus 4 is 2. Now we need to change negative 1 into a 0 using the pivot. So it looks like all we have to do are add these two rows together. So I would take row 2 plus row 3. And so row 2 plus row 3, negative 1 plus 1 is 0. 1 plus 1 is 2. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. And 4 plus 4 is 8. Next is the pivot row, so we can simply copy that down. And finally, we need to turn negative 2 into a 0. So it looks like I do row 4 plus 2 row 3. And so row 4, negative 2 plus 2 times 1 is 2 is 0. Negative 1 plus 2 times 1 is 2 is going to give me a 1. And then we have all zeros. 0 plus 1 times 2 is 2. Zeros. And then 0 plus 2 times 4 is 8. Oops, and slight boo-boo here. That should be a 1. And finally, let's identify our active variables. So we go to the pivot, and so we remove the U and we replace it with X. Everything else will stay the same. So we call the U the outgoing variable, and the X is the incoming variable. That's one way of calling it. So now, how do we know if this is our final solution or not? Once we have our table, what we want to look at is the bottom row. If the bottom row has all positive numbers and 0, we are done. Our solution is in this table. And so the bottom row, we do have all positive numbers and zeros. So we're done. All we have to do is determine what our values are. So we start with the active variables. The first active variable is s. And so to determine the value of s, we always go with the constant 2, and we divide it by the number that is in the s row and column. 1. 2 divided by 1 is 2. T is our next active variable. So we will start with the constant 8 and divide it by the number that is in the T row and T column, which again is a 1. These will not always be ones. Then X, so we have 4 divided by 1, which is 4. And then finally, P, which is 8 divided by 1, which is 8. Everything else will be a 0. So that means that Y is equal to 0 and U is equal to 0. What we're really concerned with, of course, now let's go to green. What we're really concerned with is what is the optimal value? Well, the optimal value is the value of P. So this is our optimal value. And the optimal value occurs at x equals 4 and y equals 0. So P equals 8 at the point 4, 0. That is the solution to this standard maximization problem. All right, hope you enjoyed the video. Let me know if you have any comments.